Okay, so we're going to look at this probably for our final lesson this year, this school year. So it's the volume of a cone, a pyramid, and a sphere. So a cone is obviously a bit like a cornetto cone, really. It's got a circular base. This is supposed to be a circle. It doesn't look like a circle, but then it all goes to a point. Um, Pyramid, it usually has a polygon as a base. So whether it be a square, a triangle, a pentagon, it will have some sort of a base, and then all of those vertices of that base will meet at a point. Okay, and a sphere, a bit like a tennis ball or the Earth, it is a circular object, but in three dimensions. Okay, so to work out the volume, the cone and the pyramid is pretty straightforward. If you have the height, a bit like you would of a mountain, from sea level to the very point, so it's the kind of the perpendicular height. So this would be a right angle at the base, and we'll call that h for the height. Then it's 1/3 the formula volume of a cone is 1/3 times by the area of the base. So depending on the size of this base, and because it's a circle, there is a formula for that, times by the height, and that's it. That's all you need to remember. As it's a circular base, in this case, it's 1/3 times by pi r squared, because that's the formula for the area of a circle, times by the height. And so certain things you will be given. Pi, we know what it is, it's 3.14. But if you're not allowed to use a calculator, if it's non-calculator, then usually you'll leave it in terms of pi. So you'd work out all the other numbers and then just chuck that number in front of the pi. And so it could be 24 pi, for instance. So if it's a non-calculator question, you leave it with the pi. You don't bother multiplying by the pi. Right, the pyramid. Exactly the same formula, except it's not a circular base. Okay, it's whatever the base is. So if it's a rectangle, it's length times width. So it's 1/3. So the volume of pyramid is 1/3 times by area of the base times by the height, perpendicular height. Again, it's the distance from the ground level to the very point, not the slanted distance. Okay. Sometimes they might give you that. You'd have to work out what the height actually is. Sometimes they'll give you the height. So the volume of the pyramid, the formula is exactly the same as the volume of a cone, except working out the area of the base may be different. Well, definitely will be different. So if it's a square base, it's easy. It's length times width. If it's a triangular base, it's length times width divided by 2. And sometimes they might give you the area of the base if it's something else. Okay. For a sphere, volume of a sphere, it's a little bit different. It's pretty straightforward though. If you can remember this formula, sometimes they will give it to you. It's 4/3 pi r cubed, where r is the radius from the center of the sphere to the edge of the sphere. Okay, back in going to the cone, the radius is the distance from the center of the base to the edge of the circle. Okay, so that's it. Those are the three formulas that you really need to remember to be able to work out some of these volumes. You will sometimes be given the formulas, so you don't have to remember them, but I don't think they're that hard to remember. 1/3 times the area of the base times the height, that works for both cone and pyramid. 4/3 pi r cubed, and that's the volume of a sphere. Right, let's do a couple of examples. So, example 1. I've got a sphere. I have the radius from the edge of the sphere to the center of the sphere being 11 meters. So work out the volume. Well, the formula is 4/3 pi r cubed. So it's going to be 4/3 times pi times the radius cubed, which is 11 cubed. I'm going to pop this straight into a calculator. I could possibly try and work out 11 cubed, times it by 4 and then divide by 3, but I don't think it's really going to work like that. So in my calculator, I'm happy for you to use a calculator, especially if the question lets you. 4/3 times by pi button being down here at the bottom, times 10 to the power of x when you press the shift button first, times by 11, and then we'll use the cubed button because that's the cubed button, and then we get an equal sign, and it actually gives us it in terms of pi, and that's 5,324 over 3, lots of pi. But then they might want it to a certain degree of accuracy. Let's say 3 significant figures. This is equal to 5,575.279 ... I won't write it all out. And then to 3 significant figures. First significant figure is 5, second 5, third 7. So we look at the next one, the fourth one, which is another 5. That means we round the 7 up. So it's 5,580, and because we're working in volume, it's meters cubed. So that's quite a lot of volume in that sphere. Okay, let's have a look at a second example. Remember, you can pause it, you can rewind it, you can go back and have a look just in case you're not sure. So the second example, I've got a rectangular based pyramid. Okay, what dimensions have they given me? They've told me that the short length of the base is 2 meters, the long length of the base is 6 meters, and the height, because this is a perpendicular height because it's going from the very center of the base up to the point, is 5 meters. So we've got 2 meters, 6 meters, 5 meters. So the volume, and let's remember the formula. It's 1/3 times base times height. So the base being a rectangle, so it's 2 times 6. So the volume equals 1/3 times 2 times 6 times by the height, which is 5. 2 times 6 is 12. 1/3 of 12 is 4. So it's 4 times 5, which equals 20 meters cubed because we're working in volume. Okay, last example. Okay, I've got a cone this time, so let's draw our circular base. Let's put our point up there. Not a perfect cone, I'm not very good at drawing sometimes. They're telling me that the diameter is 6 centimeters, but they're also telling me that this slanty height is 5 centimeters, and we want the volume. Remember, the formula is 1/3 times base times height. So we've got the 1/3. Can we work out the area of the base? Well, they've given us the diameter, so the radius r equals 6 divided by 2, which is 3. So I know that the radius is 3 centimeters, so I can work out it's going to be 1/3 times pi r squared times by h. Now I haven't got h. They haven't given me this height, but they have given me enough information to work out that height. If we think about this height coming down to the center, then this is what I want to work out. And this is now a right angle triangle. And we know that the radius, this distance, is 3. Okay, so they've given me a right angle triangle, and there is a theorem we use with right angle triangles, Pythagoras theorem. I've got a triangle. This is 5, this is 3, this is the height which I'm trying to work out. And to work out this, remember it's a squared plus b squared equals c squared. But if I'm trying to work out one of these shorter lengths, then I need to subtract this from one side. So a squared equals c squared minus b squared. And then to find the a, I square root both sides. So the longest length, which is always your c, is 5. So the shorter length, b, must be 3. So I can work out what the height is by chucking those two values into this formula. So h equals the square root of 5 squared take away 3 squared, which equals the square root of 25 take away 9, which is 16. Square root of 16 is 4. So the height of this is actually 4. So the volume equals 1/3 times pi times the radius, which is 3 squared, times by the height, which is 4. Well, and then pop that into your calculator and you should get your answer in terms of pi. So 1/3 times by pi times by 3 squared times by 4. Oh, with that. And I got 12 pi, that's the first thing it says. And then if we press the SD button, 37.699, so 37.7 centimeters cubed. Right, that third one was a little bit harder because you had to work out the height. Sometimes they make you do that, sometimes they don't. But if you know how to use Pythagoras, then it shouldn't be a problem for you. All right. Have a great day and enjoy yourselves.